G'day guys, welcome back to my channel. I just wanted to go over a couple of things. I've ordered the transistors for the Yamaha mixer. That's going to be in 7 to 15 days, so I think it'll be closer to 7. I ordered them from LCSC, they're usually pretty good on delivering stuff quick here. Yeah, I've got a whole lot of other stuff to do. Obviously, my own power supply. I've got a little bit of work to do on that. I have a calamity right now because I'm an idiot and I put my lamp on top of two multimeters that were stacked on top of each other. Don't know why I did that. Crappy multimeters, still don't want to break them. Right, so I have these. Why am I missing a compass? Right, so I have these two differential amplifiers. This one, some of you might have seen people discuss this on the EEV blog forum. This is actually 100 megahertz bandwidth, I'm pretty sure. It's times 1 times 10 times 100 gain. You know, diff in, single ended out. Battery powered, USB-C rechargeable. Problem with this is the switch mode power supply that's inside it, the boost converter that goes from the battery to the actual AD. I can't remember the op amps that are in here or whatever's in here. The problem is the switching power supply injects, no joke, I think it's 15.6 or 16.5 millivolts peak to peak into the amplifier. This is an LNA, a low noise amplifier. I don't understand how on earth you can use an LNA with 16.5 millivolts of switching noise injected onto it, because my scope can go down to 30-40 microvolts RMS. Actually, I've never paid attention to what the peak to peak figure is on that. Let's see. Sorry, about 40 to 60 microvolts peak to peak and about 10 microvolts RMS. So, and even if I go and move the time, horizontal seconds per division across to say 20 milliseconds, I still got 50 microvolts, 47 RMS, 500 peak to peak, 480 peak to peak. That's basically as quiet as I've ever got my own power supply that I'm building down to. Now you know why, because the scope can't see less than that. So what's the use in having something that's miles above that? I guess if you need to do some differential work that's above that threshold and you can actually see your signal, then yeah, it's going to work. But other than that, it's bloody useless. So what I did, because it's only cheap to buy it, and it comes with all decent parts in it, except for the power supply. So, well, what I thought was, we save. Let me just have a quick squeeze in here so I can tell you what it is. AD8421. So AD8421 is what's in that one. So basically what I'm thinking of doing, there's a lot of things that are wrong on this. For example, the input impedance is wrong. I should really change the battery on my torch. I think it's something, I remember looking on the forum. Actually, I just put the data on my computer so I could get this up and show you guys. I should have done it in advance. What was it? T100 LNA EV log. This one goes to this EV blog. I think I found it already. Yeah. So it's 10 megahertz bandwidth. So it's still great for a diff probe. I mean, usually you're doing power supply stuff, or I am, and you know, most of the data sheets want you to be even 8, 7, up to a bandwidth of 7, 8 megahertz is good. If you can get the whole 20 megahertz, great, but 10 megahertz is fine. So yeah, this is the problems. When the gains at 1, input impedance is 10 meg, gain 10 meg, gain 100, 2 meg. And there's no switch on it to put it in 50 ohm load or 1 meg load. I don't even know if anyone's measured the input capacitance, you know, who knows how good the board's laid out. This is one of those projects where I'm actually going to use like CAD software and design a proper board, get it sent off to a factory with, you know, controlled impedance traces, the whole lot. Capacitance will be calculated just for the board itself, you know, like it's got to be perfect. So this is what people noticed. So there's DC, 2 DC to DC boost converter. There's a DC to DC boost and a DC to DC inverter. One's to make the plus 14.6, the other one makes minus 14.6. Then there's linear regulators, so LM337, I just saw them in there, to make plus minus 12 volts. So basically speaking, all we need to do is take that out, you know, the 2 boost converters to LM337, take the rest of the guts out of this, plus a few components and switches to change input impedance, maybe a few capacitors, who knows if the components are in there, the correct components for everything. Make up a board for that, make up a power supply board, because I'm going to have the power supply board external to the box this is. Oh, actually no, that's why I got a big box for this one. This one, I got this long box so I can put the diff amp there, have some nice shielding here, and a linear supply here. Not that you really need shielding for linear supply anyway, but I mean, I want this to be perfect. Low as possible noise. So that's that project. The other project is this one. It's also another diff amp. It's only a AD 829. That might not be the part number. Let me just have a quick look. Yeah, it is. So linear gains of 1 to 20 with 120 megahertz bandwidth. What? I gotta be missing something here. There's no way this module's better than what's in here. Probably a really slow part or something. I don't know. Seems to have really good bandwidth. We'll find out in a minute. (120 megahertz bandwidth with a gain of 1). Okay. So it doesn't say with a gain of 1 to 20, it says with a gain of 1. Also, it's 230 volts per microsecond slew rate, 30 nanoseconds settling time to 0.1%. Let's go compare those figures to, what was it, the AD8249? So it's 8421. AD8421. Come on, internet. Come on. Here we go. Okay. Oh, only 10 megahertz bandwidth with a gain of 1. Really? 35 volts per microsecond slew rate. Wait, you've got to be kidding me. (120 megahertz bandwidth gain of 1 to 30 volts per microsecond. 30 nanoseconds settling time to 0.1%. 0.6 microseconds settling time to 0.001%. Hold on a sec. Nanoseconds. 0.6 microseconds. Okay. What? One moment. 829. Yeah, something doesn't add up here. I don't understand why there'd be a better one on this cheap little module. Are these different types of amplifiers or something? I should have done a little bit more research before I started this video, but well, look, honestly, it doesn't really matter because to tell you the truth, I'm doing both of them. So I might as well just get back to what I was going over with this one first. So as people have noticed, there's no AC coupling option. Oh right, there's no adjustable DC offset. There's no adjustable low pass filter, no adjustable high pass filter. The 14.6 volt minus switching supply couples. Oh wow, 70 millivolts peak to peak noise on the output. That's just insane. God. Okay, apparently the 1 times and 10 times step response have huge overshoot. They're saying it's probably from stray capacitance on the gain adjust pins. I would say they are correct in terms of it being stray capacitance, but I don't think it's between the pins, or unless they're referring to actually the traces that go up to the capacitors. I think it's poor PCB layout. You really have to know what you're doing with layout when you're doing stuff up in this frequency range. Yeah. Like Bob Pease used to say, people that do good layout, no good layout. Couldn't have said that better. So some people are wondering if the chip in here is a knockoff chip too, because it says I cannot find potential matches with the gain equation fixed internal gain resistor at 24.7k or 3k, but I have not. So I can find many potential matches, but I have not been able to find one with 9.9k. So I think what someone's getting at is that maybe there's a different part in here and it's relabeled, and that's why the gain resistors don't match what they should match in the data sheet. Doing math off the data sheet. Yeah, that's true too. There's no charge, no power on LED. Well, there is an LED on it, and it comes on when you charge it, and it goes off when it's charged. So that's not true. But there is no power on LED, and there's no low battery indicator. Mm. Yeah, see, I suggest you stick a decent in-amp along with the front end. You need filtering, AC coupling, etc. That's true. You need a shielded box and hook 2 9-volt batteries to all. That wasn't exactly how I was going to power it, but yeah. I've got a bit of learning to do myself. I'm not an RF guy. I don't know a lot about high frequency stuff. I do understand, you know, like I've been saying, strain capacitance, board layout, controlled impedance traces. I'm not a complete dope, but I'll need calculators to do it all, and software. It's not like I could just do it myself. So anyway, I'll have a read over the article up later, but basically I've got that to do. So I don't know how many parts I'm going to have to order for that. I'd imagine I'm going to have to order a few parts for it, because I'm going to want really, really high quality parts in my build. I'm obviously going to have to design a PCB for it. I have not used CAD software for more than 5 minutes in my life, even though I have it. I only used it for a couple of small things I've absolutely had to use it for. I just don't, yeah. So it's going to be a bit of a learning curve on this one. So it will make for an interesting series, I guess. Could be a few screw ups in it. Hopefully no major screw ups, like we popped the AD, whatever it is, 8429 or 8421 or whatever it is, I can't remember. Because that would be bad. I might actually start on that little one first. I also might just do a bit more research on these two chips and try and work out what the difference is. I really have no clue. I haven't read data sheets for either of them. I don't even know if they're the same sort of part. I don't know if this is just a difference amplifier, if this is an instrumentation amplifier, if it's an op amp, if it's a low noise amplifier. I don't know. Yeah, I've literally just seen slew rate and bandwidth, and that got me thinking. So anyway, I've got those two projects. And by the way, this will either stay SMA, because I've got SMA to BNC adapters, or we'll put BNC on it. That is if this board turns out, it actually looks like it was laid out properly. Like I can actually see what appears to be controlled impedance traces with ground stitching, but the traces do look It could be right. It could be right. I'll have to do some research into it. Like I said, this is not my niche. I've got a learning curve to go on here. But that's two things to do. Then I got this high voltage breakdown tester, popped a current shock resistor in it, made a stronger resistor up in it, out of some bigger resistors in heat shrink. That works now, so we can do high voltage breakdown testing on stuff. Goes up to like 3700 volts, or a bit shy off of it, but more than the 2700 volt, the last model that they released. I got that, and don't forget I got the Atlas DCA 75 Pro. So with that and that, we can do some transistor testing. I have a curve tracer that I started building when I was a bit younger. And then I came back to it when I was a little bit older, bought some panel meters and some shunts and stuff, tried to add more functionality to it. And, well, basically the panel meters are not as accurate as I wanted them to be. what else? Oh, the video output stage never got finished, and it was all made on perf board. I wouldn't mind going back to that and taking out basically just the driver board that I made, which was off memory like a 555 with some like really expensive capacitors and resistors for the oscillator section, so that it was really stable, and stuff that you could switch in and out to adjust the frequency. And I think that went into, I can't remember what they are, CD4017, CD4016, something like that. And I was using that to generate a staircase waveform. It's been that long since I've built a curve tracer, so I can't even remember it further than that. But I want to take that driver board out of it, and then take the amps and everything in there that I built in there basically out of it, harvest the parts out of them and make up a much bigger, more powerful one. I might be able to just upgrade that, I don't know. I won't know until I have a look in it. I think I'll be reusing some of the stuff in it and some of it will just be getting remade. But that's another thing I've got to do. I've got, I think I might have 2 amplifiers. No, one's the Yamaha mixer that we started on. So I've also got a Denon amp that the transformer needs to be substituted or remounting. Or if it's just the thermal fuse and I can actually get to it, we can just fix the thermal fuse. So I've got to look at that. The reason I'm making this video is because I want feedback. I want to know what everyone wants to see next, what sort of projects interest people the most. I decided I wanted to build a diac tester. The reason for this is I commonly harvest components off boards, find diacs, and kind of identify them, the voltage they break down at, fire at, whatever you want to call it. So I want to build a diac tester. I guess I could probably, in a crude fashion, use the high voltage breakdown tester, because it actually does go down like 40 volts, and put a meter across the diac and winds up with it current limited really low. But I want to build something proper, What else have we got here? I still got that Pong chip to try and build. I need to sort out the other IC that goes with it. I got one of my channel members or subscribers that watches some of my videos gave me some information on it, which is really helpful. I know what to do with it now, but I still need one more IC. I've got a TV that I need to have a go at fixing the backlighting. I've got a few other things too, like I wanted to build a low noise FET probe, like a super low noise probe. Oh yeah, like I said before in my last video where I was working on the, what do you call it, the mix amplifier, I still want to build another power supply for myself, not just the one I'm working on that's just a normal 30 volt 5 amp constant current, constant voltage, like 1 milliamp, 1 millivolt accuracy. I want to make a high voltage switching supply, so that's another project. I'm not too fussed on the accuracy of that, that's just more so I have a high voltage supply, as long as it's roughly 10 millivolts accurate, a milliamp accurate, I'll be happy, heck, even a couple milliamps, milliamps easy to obtain anyway. What else? I've got a few other things that are arriving, like parts for builds that are arriving, so I've got a few amplifiers that I want to build. I've got a whole load of 2C5200s and some other random parts arriving, so I can do them. Same with load banks. I've got some huge non-inductive resistors that I'm saving up to order. I haven't ordered those yet. And then I'm going to build some low inductance load banks, so that when I get my Quantasylum, I've got a low inductance load bank to load amps down and look across. I've got some smaller power supplies too. So like I have. This is another project to do. I don't want anything special out of this, but this is just an old Motorola radio power supply, whatever you want to call it, you know. And it's got a chunky ass transformer on it, a couple of 185 transistors, or M9639s, or maybe they're 9206s. There's three numbers on there, I don't know if you identify, but it's got that driver board in it, which is just a few it's a 2 transistor Zener regulator, and I'm quite happy with that for what this is. All I want to do with this is basically bring a pot out to the front so you can control the voltage, change this area to panel jacks and add an earth to it, add some common mode suppression, and transformer looks a bit melty. And add very crude current limiting, like, you know, just a very simple fold back current limiter or something like that. You know, just so that you can dial it down to, you know, a few milliamps to 100 milliamps to amps. You know, nothing special. But that will be another supply. Right, the audio, the Yamaha mixer. I've actually ordered the transistors. I was tossing up whether to take the power supply out and halve the components out the amp or not. I ended up ordering those digital, whatever you call them, logic level transistors with inbuilt base emitter and base resistor. So I've ordered them. Like I said, they'll be in 5 to 7 days. I'm just trying to work out what to do in the meantime. I've got some power supplies to analyse. I've got a switcher from Owen with a multimeter in it, and I've got a linear dual tracking 2-channel supply to analyse. I've also ordered the parts for this Tektronix DMM916 finally, so I've got everything coming for that. All the chips except for literally the main processor I've ordered, so that got destroyed by battery acid and it ingressed. It sort of wicked its way up pins, legs, and destroyed ICs internally. What else? I know there's something else. Oh yes, I need to build one. I'm thinking 2, because I probably want 2 of them. Some microamp supplies. So that's something else that's coming up. I've already ordered some parts for it, but I've got to wait for them to arrive, like some precision op amps and stuff like that. I haven't actually decided on the op amps. I haven't ordered the op amps for this particular one. I've ordered some op amps for some other things, but I was thinking about going with the Maxim parts Dave Jones is using in his microcurrent, but I might actually be ordering some better ones, because this is going to be a full microamp power supply, not just a microcurrent module that measures microcurrent. You know, so leave it in the comments. Tell me what interests you guys, what you guys want to see. Because obviously I've got a lot of stuff to do and it doesn't really faze me what order I do it in. I just want to get it done. But whatever people are more keen in seeing, obviously that's what I'm going to bang out and get done first. I want to keep everyone entertained. I want to get the channel to grow. I want to get people to like and subscribe and all that good stuff. So give me some feedback, because every time I post a video and I ask for feedback, sometimes 1 or 2 people give me feedback, or I'll see like a like on the video, but that's about it. I don't really get much feedback. So yeah, if you guys could give me some feedback, that would be wonderful. Oh yeah, multimeters. I've got 2 magnets to fix. I need to check the values of all the shunt resistors in the current section in this multimeter and clean up the range switch. The fluke, I just need to clean up the range switch. The DMN 916, that's the total repair. So that's what there is. Leave your feedback in the comment section. And don't forget to like and subscribe. Thanks for watching, guys. See you in the next one.